So my name is Joy. As John mentioned, strategy and development is part of my portfolio. I also have strategic accounts, and one of my key focuses as well is to take greenfield products within our ecosystem through to commercialization. One of the really interesting verticals for us has definitely been education. Through the slides, I'll share a little bit more about some of our experiences in education, some use cases, and of course that's where Martin will come in to give you a bit of an overview as to our joint collaboration together. But also, how we wanted to run the session is also talk about some of the key trends that we're seeing in education. And we'd love to hear your thoughts as well. So if there's any questions, please put it in the chats if we can't get to it. I also have a team member of mine, Rachel, who's on the call. Rachel heads up marketing and partnerships as well. So we're here to answer any questions from the team. A little bit about MeldCX and who we are. So MeldCX stands for Melding the Customer Experience. We're a long-time Intel partners. We've got multiple partnership tiers with Intel. Not only are we part of the AI ISV program, we also have market-ready solutions out there. So, if anyone wants to know more, please do give us a shout out, and we'll definitely take you through those. As for us, we have, companies all across the world, or branches all across the world. We're strongest in APJ and America. And we also have branch offices in the UK, and we'll continue to grow operations. As you can see on screen as well, we're a largely channel-based business. So you can see a huge range of some of our tech partners that are up on screen. So obviously Intel, as you can see, and we also have, the likes of Google, Microsoft, and we also work with a large range of OEM and ODM partners. So the product that we wanted to introduce to you today is one of the products in our product suite. That particular product is called Viana. So Viana is short for Vision Analytics, and essentially that is our AI and machine learning based product that we like to say enables machines to see the physical world and then use our platform to be able to make sense of it. So that's what we see and we want to do. And essentially, through that product, be able to augment what they see, make sense of it, and then eventually be able to produce, interventions or help, the model continue to grow. So that's essentially Viana and what we do. We generally see Viana as being used in multiple ways. So education is definitely one of our verticals, but we see Viana in a customer experience way, and we've rethought how we position the product in market. So essentially, what we like to say is that Viana helps to solve 4 different customer experience needs, and those 4 pillars are up on screen right now, where you've got pillars like space analytics, you've got pillars like advertising, pillars like product inspection, and then safety, security, and health. As you can see, we also have a bunch of, off-the-shelf products all the way to customized or personalized products. So as you can see, the arrow, it steadily goes to the customized end as it goes to the right. So space analytics is essentially being able to map and understand a physical space. So we're understanding things like how does a customer interact with, a particular space, and that could also be extended to vehicles. So that's how vehicles, spend time in a drive-through, how are people, do females prefer to go in and pick up, sparkling water versus males? There are little things like that. That's all in that, smart spaces vertical, or basically smart spaces use cases and outcome. Then we also go to smart or programmatic advertising, which is something that we're working with a lot of our advertising partners on. So that's all about eyeball to content metrics. So that's essentially, things like understanding, who's standing in front of the screen and showing up the right content to the right person. So if Martin stood in front of a screen versus I stood in front of the screen, different ads would play. I'm not sure if any of you were at Intel Connection in Sydney, or if any of you were at Intel Innovation that's actually just bumping out right now. But those are some of the key modules that we showcased for those 2 shows. Moving forward, we also have product inspection, which is essentially object detection using, ML language. And that's essentially where what we're going to show you if Martin is going to sit in. So essentially, it's here where we're going to understand things like, in a manufacturing space, whether things are labeled correctly, whether the right QR codes are put in. And from an education vertical, we're actually using object detection to be able to gamify how students are actually interacting with Lego blocks and, that whole tangible experience of building something and learning about it. Further down the track as well, we also have use cases and a couple of key modules for safety and security. A lot of this is essentially around behavioral analytics, and we'll show you a little bit as to how we do that and how we use synthetic data sets to be able to train and to be able to help our customers get to a good baseline accuracy quickly to drive POCs. So back to education and what we're seeing in education. We've got a little slide up here that hopefully can help everyone visualize what we see the connected campus as. So as you can see up on screen here, everything that is in the boxes are actually available basically plug and play. All you really need is a camera mounted in the right height, and we can basically run these use cases. So as you can see on screen, these are all off-the-shelf modules. They range from things like, occupancy, so understanding, dwell times in a specific zone, all the way to, as I mentioned before, smart signage. So understanding if, say, as we're walking through, there's certain ads for certain modules, which is quite popular in universities, are actually getting, traction with students. And you also can see things like our safety and security module in the middle, where we can set things like, contact and time thresholds on cafeteria tables, so we can deploy cleaning stuff as needed. So these are a couple of use cases that we see in the connected campus use case, and we've got customers who are talking to us about that all the time. So we've also summarized a couple of key trends as to some of the things that we're talking to education providers on. So one of the key things is definitely we see a differentiation. In Australia, we say K to 12. So that's essentially, for those in America, I guess from high school and below. And then we see a definite need for universities and, higher education institutions and some of the key trends that they're looking at. So one of the key things that we have seen in education, especially for K to 12, which is, between like 16 and below, essentially, we're seeing a lot of requests, especially for access control. So that could be for people and also for vehicles. So we actually sat with a private school in Australia, and there was a particular situation where there was a domestic case, and there was a particular individual that was related to the child that picked up the child without the other parent knowing, and so that caused a bit of friction. So we're working with schools in this way to be able to provide access control based on vehicles, LPR, and the like. We also work with them on things like room utilization and zone engagement. A lot of these two use cases are definitely for universities. Not in a bad way, but I think the older you get, the more you kind of want to use your time more effectively. And universities are finding that they may have certain dropout rates for students for certain classes. How do they understand that? How do they do facilities management a little bit better? Are students wanting to hang out in the foyer a lot more? Should they increase services there? Things like that. There is also a particular use case for a certain boys' school in Australia as well, which has a really, really interesting use case. So this is around attendance and roll call. That particular use case was the school actually came to us and they said, hey, MelCX, we're having a couple of issues of attendance and roll calls. So one, the students usually have a really good relationship with some of their teachers. They know some of the things to bend with their teachers. And so they could walk up and say, hey, sir, I know this is the last class, it's only like an hour. Can you just mark me as present? I'm gonna head off and do a party. A bit surprising, but it's actually happening. And the second thing is, they also have teachers in attendance and roll call where they have a large classroom, and instead of actually checking who is present, they just mark everyone as present and just submit the roll call sheet. What happens after is basically they were actually put to a little bit of an audit with the local state government, and the local state government found that this particular student was consistently marked as present during the period of COVID, but it actually turned out that that student was actually in Singapore with their parents, and there was a bit of an issue because for the particular state, the government would pay out grants for 75% of student attendance and above, and so that became a little bit of a sticky situation for the school. So that was one. Some other use cases that we have include making sure that students are actually in campus during school hours. We actually had an incident whereby, which is quite smart and enterprising, this particular boys' school had students who were actually inside the school zone, but they actually weren't attending classes. And when their headmaster found out, he actually went and did a search, and it turns out that these three boys were actually in one of the toilets in one of the buildings, and they were actually running a barber business. So the next day was essentially, school checks for uniforms and making sure your hair is in the right, length and all of that. So they're actually running a barber business where they were actually cutting their fellow peers' hair to just earn a little bit of cash, and they actually skipped half a day of classes because everybody was covering up for them, which is quite smart, but obviously they should be in class. Some other use cases also around kind of access control and entry and exit monitoring was making sure that students are not supposed to do this, but sometimes they don't like cafeteria food. They would order like Uber Eats or food delivery, and they would sneak out of campus, pick up the food, make sure the Uber driver dropped it off one street, before, and come back to school and get their peers to cover up for them. So all these little incidents together make it really hard for an educator to look at how to protect the students in your care. And last but not least, of course, and this is what we're going to talk about today, is not only using what we can do for AI ML in the periphery of looking after students, but also embedding that into the actual curriculum to help students grow and learn. And that's something that Martin, who's on the call as well, will be taking the team through. So a little bit of what we do, we actually have a video. So for those of you who are interested, we'll make sure that this video gets sent out, if not so on our YouTube, where we actually show the AI playground in EduTech in Melbourne, and we actually did a little bit of a video with it. But essentially, just laying a bit of some of the tech side of things. Some of the key technology pieces that we've used to run AI Playground include object recognition and also visual environment simulation. So we'll talk a little bit more about the edge use cases slightly later on, but I'm going to pass that over to Martin now to give everyone a bit of an overview of our collaboration together. So over to you, Martin.
Yes, thank you, Joy. And also thanks to Daphne and John for making this possible to present our AI Playground and work on AI in education to the Intel audience. It's a great pleasure to be here. And I personally have had the pleasure to work with Intel and MeltGX already since 2020. So it's been a very productive relationship. I'm not sharing my screen, so I will ask Joy to advance the slides, and if you could maybe move to the next slide now, that would be quite useful. Yes, thank you. So I'm co-director of the Center for Change and Complexity in Learning, which is a research center at the University of South Australia. We have about 55 researchers employed within the center, and we have about 35 PhD students working with us on education technology related projects. And our main work is in the education technology area, trying to understand sort of the digital and AI transformation of AI in education. And we will come from a critical lens. It's, understanding the opportunities and barriers that AI and digital tools may have on the arrangement of education, but also on the learning experience. So it's not necessarily always for the good, but we need to understand sort of the ethical components of it. How do we deal with data? What are the key opportunities to advance the use of AI, and how can that be done in a particular way? If you could move to the next slide, Joy. So within our research center, we have a few leading programs or research trends, if you like. And the first one is on human and AI cognition. It's about understanding the integration of non-human intelligence, if you like, in human behavior. So how do humans and AI or smart technology work together? Understanding the ways in which that can be done, understanding sort of how that might change on how we perceive technology, but also how we perceive decision making and how that's done in human systems. Another area of work is learning analytics, and this is very much data driven. It's understanding the traces of data, and Joy already talked a little about that, understanding data for learning and teaching, and see how that can help us gain better insight in teaching and learning processes, help inform and augment, if you like, the design of learning activities, but also to provide more personalized and adaptive learning opportunities and feedback to students themselves. So you can think of it as a bit of a leaderboard. So through the learning analytics, we can trace the student activity, we can monitor how they are doing, we can assess well-being to some extent, and we're particularly also interested in, at this point in time, of course, how AI can be integrated in learning analytics to help automate particular processes, pattern detection, and provide recommended feedback to both students and teachers, but also to parents and school leaders. The Leadership and Complexity research program deals with understanding how the education landscape is changing, particularly due to the impact of AI and smart technologies. I think we all sort of realized at the end of last year, beginning of this year, how particularly with OpenAI's chatbot, the ChatGPT sort of had a huge impact on daily operations, and this is the same within schools. So in our center, we've been working on AI for quite a number of years. Like I said, we've already worked with MeltX and Intel since 2020 and knocking on schools' doors to talk about the importance of AI and how AI will probably or has the potential to transform how we think about education, how we deliver education, and how kids experience education. But since beginning of this year, there is an enormous uptake and an enormous interest from schools to understand more. So previous year explaining why AI might be important and how it will have an impact, and all of a sudden this year we're running AI literacy courses where more than 600 teachers are signing up just to get an understanding of AI and how it can work, and of course provide training and upskilling to teachers to start understanding how they can integrate AI into the education, which is also part of our Futures Thinking program, just to help practice and industry to understand sort of what are the future opportunities for developing new tools and technologies to support education. And thank you, Joy. One of the major opportunities that I'm leading at the moment, besides the AI Playground, is the development of a cooperative research center application, which we have called AI Live. And this is to deal with the upcoming and sort of the current sort of fragmented landscape of uptake and understanding of AI in education. So as you can imagine, lots of AI companies are building tools or are playing around with tools in education. Schools are understanding and working their way through potential uptake of AI, but this is all done in a very fragmented sort of space. And what we lack at the moment is coherence. We need to have better AI frameworks. We need to start developing particular standards that can help schools to assess the potential and the impact particular tools may have. It's about creating ethical standards and security for AI and data management in education. So there are some really big grand challenges at the moment around sort of understanding the potential impact of AI in education and bring that thought and development leadership together to start creating a bit of a roadmap going forward. And this cooperative research center bit is there to help achieve these things. So our mission is to empower citizens for a life with AI, and it's about building trusted, responsible, and secure AI for education, together with industry partners, but also together with departments of education and large school systems, so that we bring, if you like, the supply and demand in conversation, and all of these collaborations will be underlined with research to provide an evidence-based foundation for understanding the AI for good in education, if you like. And these cooperative research centers, they have a lifetime for probably sort of 5 to 10 years, so it provides a very fruitful ground for collaboration and building new tools for AI commercialization in education. Maybe go to the next slide, Joy. So one of the examples, of course, that we will be driving also through the CRC is the AI playground, and here Joy already gave a few examples of AI in education, and some of these examples are dealing with sort of process tooling, sort of understanding the use of the smart campus, where are people, what are they doing. But another key component of integrating AI into the classroom is really understanding how AI can play a role in classroom practice. And there is a bit of a limited sort of development of tools that can really be integrated in the daily curriculum, where kids learn to play and experience AI and use AI to solve particular problems. Can we have the next slide, Joy? So with the AI playgrounds, we want to create, together with MelTX and Intel, a safe space where kids can deploy and work and basically experience AI through play. So it's the idea that the kids can take ownership over AI, and through creating and playing with it, they increase their understanding of AI, but also create a pathway for them to see how they can utilize AI to solve their own particular problems. And those are big challenges. I'm not going to say that the AI playground at the moment will serve all these needs, but that's sort of the bigger vision that we have, so that kids can, almost like playing with Lego, you can almost create anything out of Lego that sort of fits your needs based on your own imagination and how you see particular solutions or designs in the world around you. Together with AI, we want to see a similar pathway where kids are confronted with a particular problem, and that they learn how to integrate AI and develop AI in order to solve these particular problems. Maybe go to the next slide. And within the playground, we will offer what we call AI challenges. So the playground is a space where a number of AI challenges can be offered, and they can be integrated in the classroom curriculum based on the subjects that teachers are teaching. And the one example that we will show at the moment is all about the Mars rover, which is all about identifying and learning about space. Will there be life on Mars? Is that all possible? So that's the sort of the bigger challenge that the kids will be engaged with. And through the AI playground, they will be building a Mars rover and then create a digital twin so that they can drive virtually on Mars and test sort of the capability of their rover and the sensors to start collecting data. So really that notion of using AI to build a particular solution to solve a big question or a big problem, then also create that, test it out in a digital space through digital twinning, running simulations. And I think those are two very key opportunities when you start looking at integration of AI into education and have kids to start thinking about how we can create in a sustainable way new solutions, but test them out first through simulations before having an impact in the real world. And that's a way of learning and testing and development going forward that's going to be very impactful in the marketplace, and kids need to learn and develop these skills early on. Besides the learning activities of the kids themselves, through the playground we will also collect, like I said, data to develop a leaderboard to gamify, if you like, the learning experience for the kids. But the same data will also be used to provide feedback to the teachers and students to understand how they are doing, what kind of progress are they making, and help them focus augment, if you like, their learning experiences by guiding their pathway forwards. There will also be lots of teacher resources, because the integration of AI in education is not something that can be done without further teacher support. So teacher training, there will be lesson plans and manuals on how to set up the playground and work with the lesson plans that are there. Can we go to the next slide? So basically, within the playground Mars rover exploration, the kids will have work in groups, basically. So it's all about collaborative learning, and what we try to do is to combine real classroom interaction and practice sort of around the table together with AI. And like, there will be on the grand challenge to start exploring life on Mars, and the first step is to really create that Mars rover, and that'll be done together with Lego and the integration of AI. We will show that in a minute. But in the background, the complex problem-solving models, that's basically the key skills and capabilities that the kids will be learning. So it's about the capability to translate a problem into a learning pathway, so to speak. So it's about defining the task, understanding what we're all trying to achieve, brainstorm solutions, start building some designs, test your and implement sort of your designs, and then analyze and review the results that you have along the way. And basically our learning analytics will capture through the interactions that the kids have amongst themselves, through the interactions the kids have with the AI, and how the AI is being utilized. We will try to develop models to help guide and analyze, if you like, their transition in this problem-solving pathway. Okay, the next slide, please. Takes a while to load, maybe. Okay, so when the kids are in the AI playground and working on the challenge for the Mars rover problem, basically, the AI will interact with them or support their learning in 4 particular ways. And what you can see here at the desk is that the kids sitting around the table, and they are figuring out with the Lego blocks sort of how to build the Mars rover. And this will be done without a Lego manual. So we created our own Lego rover. It doesn't exist within the Lego, so it's not a design kit that you can build or buy up front. And the important idea is that the kids will explore through conversation, through testing, sort of, okay, well, how can we build this Mars rover? And at the left corner at the desk, you can see a camera, and that camera is looking down on the desk. And that's basically a way to engage with MeltCX Viana platform. So the camera is the eyes of the AI, and it will help to detect what the kids are doing. And the first step where the AI is helping is with the object, the detection that Joy was explaining earlier on. So when you put particular Lego bricks on the table, the AI will look at them and of course try to detect them and give the kids feedback about sort of what the bricks are, how they can be used to build Lego structures like the rover. And once you sort of understand sort of what the Lego bricks can do, then you can start moving to the second sort of support, and that's about guidance through designing the rover. So through the interaction and the support of the AI, the kids can build the rover for their Mars exploration. And part of the rover build is also to add sensors, because you need sensors and motors to collect data and drive around on Mars itself. And that's where you start to prepare the understanding and the importance, if you like, of digital twinning. So while they can drive the rover around in the classroom and see if it works, they can also test and connect the sensors and see if they are capable of picking up the data that they need to collect while they're on Mars. And then as soon as they are on Mars, they can switch on the sensors, connect them with the interface basically on Earth, so that you know, okay, we have our eyes on the ground and we can start collecting data and analyze that data. And fourthly, a more important thing as well is that while the kids are interacting with the AI, it's of course understandable the AI is not perfect yet. And I think that's a really important thing, because kids particularly they are exposed to AI, particularly through movies and books and things like that, that AI is always perfect, and kids tend to trust the AI, you know, whatever Siri tells them is sort of right. And it's important through this process that they start to understand that AI has its limitations. It has its limits in its capability. It might make mistakes similar to humans. And what they can do in the playground is they can provide feedback to the AI if the AI is not giving the correct sort of feedback or response. And they can help, therefore, by collecting this kind of data to keep on training and improving the AI. And through that process, they will also realize that maybe their AI in their group might perform quicker or more accurate than the AI of another group. And of course, there will be a reset button for teachers, you know, at the end of the course if they want to set everything back to sort of a ground zero. But the idea that the kids are actually training and building AI models is really important. And it's also important to point out that the kids own the data. So they have complete ownership over how the data is being used and where it goes next. Okay, can we have the next slide? So to create a little bit of an understanding of what's happening in the Mars rover challenge is that in the picture on the left, you get to see the Mars rover that they are building. And basically the Mars rover is based on the Lego sets that are heavily deployed in schools already. So they don't need to buy additional Lego because most schools already have these EV3, they're called Lego sets, which come with a high number of bricks and wheels and computers and sensors, and they're all being used in relation to the Mars rover. So first of all, they need to select, and then you see that on the right picture, a component part that they are going to build. So here you can see that they will be building the tracks on the right side of the rover. So if you click on the tracks, and maybe we can click on the next slide, you will be taken to the interface, the AI Builder app, that will help the kids to guide through their building stage. So basically there are three key components here in this screen. So on the right side, you see what the camera sees. And as you can see, the camera is only looking down, it's only looking at the desk. So it's not taking any facial recognition or human data in that sense. It's all about looking at the Lego pieces. And in this particular example, there are three different Lego pieces placed on the desk. And in the row at the bottom of the screen, you can see these cards. And there are three cards here highlighted. And that's because there are also three Lego pieces highlighted on the table. And in these cards, you can see what particular Lego piece it is. And it will also give the feedback whether they need that particular piece for this component or whether they don't need it. So through working with the cards and the object identification, the kids are able to select the Lego pieces that they need for this particular component that they're working on. And the AI will give them the feedback, like how many components they need. So in the green markers, you can sort of see like this cog they need 2 of, or this red connector they need 4. And once they have collected all the pieces in the card selection further down in the below bar, then they know, okay, we've got all the pieces, and they can continue to build. Or can we just go quickly back to the previous slide, because there is one important part in the blue screen. In the blue screen, you see the 3D model of the component that they're building, and as soon as the objects are identified, it will highlight a particular object in the 3D model. So the kids can interact with the AI to see where the Lego pieces need to be. And that it will be a great guidance for them to build the model, because they can sort of simulate themselves way through the 3D model, and they can rotate the model and they can zoom in, so they can really identify where each particular piece needs to go. And it's up to the kids to decide how much they want to use this AI, if they only want to look at the 3D model, or if they want to use the object detection to understand where particular pieces need to go. Thank you, Joy. Maybe now to the next slide then. So as soon as the components are detected and when the components are collected and integrated into the Mars rover, there are particular stages where you can sort of identify your progress. So each component will be identified as being ready, and once you have put all the components together into the full rover, you can present it to the AI as well, and the AI will then give you feedback whether it's developed, and it gives you some nice sort of feedback like, oh, great work, well done. And when you're ready, then the top button in the purple button becomes available, which means that you can now start to travel to Mars. Thank you. Yeah, that's the one. And this will, you can go to the next slide. This will present you with a transition video where you get to fly to Mars. And then as soon as you land on Mars, which is the picture on the top or lower right corner, that's where you will land then at your base camp. And this is then where you get to drive your Mars rover on Mars, and you can go on a number of missions to start identifying Martian landscapes, but also you can trace back, maybe go next to the next slide, you can trace back to particular spaces where the NASA Perseverance rover have been. I think, yeah. So in the top left picture, you see a 3D model of the Perseverance rover, and you can drive around and you can cycle through all the instruments and sensors that the Perseverance has. So this is a great way to understand about the why sensors are important and why you have integrated particular sensor in your own rover, and that of course helps with that whole development of digital twinning and try to do stuff and collect data in a remote location, but still use the data and analyze the data, in this particular case on Earth. So basically you can trace back sort of what the Perseverance has been doing, you can learn from it. There are a few hidden gems and gamified sort of missions where you also will stumble upon other Mars rovers, and the Ingenuity helicopter will be there as well, so you can really see what humans have been doing on Mars. But also you can drive around and collect data through a set of missions, and in the picture in the lower right screen you see that there is a bit of rock drilling happening. So you have a robot arm that will sort of go down, collect data about certain rocks, and then the data will be sent to Earth for the kids to further analyze in the classroom. Okay, maybe go to the next slide. So this has given a bit of an overview of how the kids will actually integrate with real AI into the classroom. And basically what we're doing in our research is to understand how kids accept, if you like, and learn to play with AI in their own collaborative learning. So will they see AI as a key team member, so to speak, and for us that's really interesting to sort of see how kids develop learning theories and ways to collaborate with AI, and that's really important to building capability towards the future workforce. A lot of time is also invested in understanding and working with teachers how we can create exciting lesson plans, but also how we can foster learning about AI through teacher professional development and integrate AI in the classroom practice. And it's also focused on how kids and teachers develop trust in AI and create sort of their own ways of understanding the capability of AI and build new AI approaches and models going forwards. Next slide, please. So going back to the complex problem solving model, basically the kids are working on the challenge, and through their learning experience we will be collecting data about how they are engaging, and the data we will use to analyze and augment, if you like, that learning experience. So we will be collecting data about how the kids are engaging with the tasks, but also if the kids are working together, if they're on task or if they're sort of off task, and if they are growing through the progressively, if you like, through the problem solving cycles. And if that's not happening, then the AI can sort of signal to the teacher that this particular group might be dysfunctional, if you like, or highly not collaborative, or talking about other things, or working on other projects. And it will give them certain nudges and also positive feedback, like, okay, this is going really well, maybe it's time to go to the next stage and start testing your model and things like that. So Joy, I think this is what I would like to share. I think the next slide is about the Intel technologies and edge devices that we are using. You might want to talk a bit more about that, but in the slide previously I showed you that we are using sensors like the cameras, and that will directly feed into the Viana for the AI capability, and it's run on Intel Edge devices. Currently we're using NUCs, but I think that's about to change. Maybe Joy, would you like to catch on?
Yeah, of course. So thank you so much, Martin. And for anyone who has any questions, please, put them in the Q and in the chat so that we can have a look at them. Or I'll try and make sure that we save at least 5 minutes for questions at the end. So like Martin said, this is an overview of the solution diagram, what we're currently using. We are actually using an Intel NUC Extreme at the moment. However, we are also testing Dell and Lenovo devices. So, obviously with everything that's happening with the Intel NUC Extreme and the move over, so we're just testing a couple of devices. But in summary, we do have a package for this as well, and we do have a SaaS licensing model. So that's all per endpoint per year, and that endpoint is actually to the sensor, which is the camera in this instance. So I know we have about 10 minutes, so I'm going to try and run through some of these slides. And as always, if you've got any questions, want to chat a bit more about education or any other AI use case you might have, please always do reach out. I think just to quickly summarize some of the things that we're talking about with AI in education, I think we generally see 3 key trends across it. So one obviously is, trends and requirements for curriculum-based AI training. So that's essentially what Martin and the team is doing. So incorporating AI into the actual curriculum to help grow and learn, and that's the key outcome. We also have particular use cases where we're also looking at an AI-based encyclopedia, for example. So very similar to what Martin is looking at, with Lego bricks. But this time we're also looking at raising certain key pictures. So for example, we call it a picture of a particular animal and being able to see a video of it as well, so to explain what the animal is, so that AI-based encyclopedia. So that's all curriculum-based. The second key trend that we see with AI in education, which I mentioned a little bit before, is situational based. So that's where all the things like access control, all the things like students stepping out when it's during school hours, that's all incident based. So that's some of the other trends that we see. And the last trend that we also see is a lot to do with facilities-based requirements. So traditionally, that's for us in my dealings with some of the educational facilities, that's predominantly in universities or higher education settings, where people are looking at, hey, I've got X amount of students, how do we map out students coming back to campus after COVID? Do we need to amend certain things? How do we retain students actually coming into the campus and having a good campus life? Which honestly is one of the best things of university. So other key topics that we're looking at for education also include things like subjects of facial recognition and biometrics. So that's really, I won't say it's surprising, but it's definitely going to be a key topic for us as we unpack, especially for students below, 16 or 18, how we deal with the whole idea of facial recognition and biometrics. As well as some of that information with regards to students. So that whole topic of safety, security versus privacy continues to be one of the key points in education that we address with AI. So I'm going to try and run through the rest of the slides as quickly and as logically as I can. But essentially, I just wanted to share a little bit, some of the things that Martin was talking about, how we train. That's some of the things that we train for object detection. And we apply that same logic to what we do for behavior as well. So a lot of what we do is based on 3D simulation, just so that we can get a simulated environment to do certain hands and actions repeatedly and get to a good baseline accuracy before we put that out on field. So what you see on screen is what we've done for one of our loss prevention customers. So I'm going to skip through this. I want to talk a little bit about the role of Intel and why Edge. So these are a couple of things that we've put on screen as to the benefits of training and the Edge and why we love Intel so much. It's also something that we continue to inform our customers on when we always have that conversations of cost optimization, of things like, why, how do we do certain things? Can we move to a VM? These are always some of the things that we talk about. So one, obviously, is security. When you have something locally, you can lock it down. You've got key things like, TPM on devices that really kind of helps put security, locally. And there's been so many cases, especially in Australia, of data that's been breached that I think this has started to kind of stick with some of our customers here. The second as well is speed. Obviously, with that additional grant for processing, data can just be gathered and visualized, in near real time. And I think that's really important for some of our customers. And we continue to remind them that, especially in incidents where access control or security has been breached, from a physical space scenario, you do want things to come as quickly as you can. It's, situations where every second really counts. And obviously, there's that reliability piece where you can actually push applets down to an edge device and not have to worry about the cloud. So that's something that we've been talking about to our customers a lot in some of those conversations. We also wanted to put out there some of our USPs with the MELT, CX, and Intel collaboration. As you can see on screen here, a lot of things that we put on is about being able to stack not only multiple AI models, but multiple AI use cases together. So obviously, what that means is, as you saw from the connected campus visualization, a particular school or education, provider is able to get an understanding of your entire physical space by pulling together these building blocks of AI to help match what they want to achieve, either operationally or security-wise, using AI. So that's been something that's been really useful for our customers. The third thing as well is we really wanted to make the edge work for customers across kind of the spectrum. So, we can work, and we always recommend, a higher format, GPU for things that need a lot of processing power, like loss prevention. However, one of our key points is also to be able to harness the best of Intel compute on the CPU to ensure maximum ROI. So that's some of our USPs. Something to also talk about, I love this tagline because it's so true. With great data comes great responsibility. And we always talk about this. We spend a lot of time to make sure that the way we store, capture, and process data is in line with some of the global standards of the world. As you can see, we've been independently verified by a third-party agency that how we do all these privacy practices is in line with what's out there globally. So in summary, that's really us. We always encourage, especially for education providers or even multiple verticals. This is our motto: start small, prove value, and scale. And it's worked for us. We start really small, prove the POC, prove the ROI, use data to show that we can really bring value to the particular business problem or to the use case that the customer wants. And we grow with the customer in that sense. So I'm going to breeze a little bit through this, but this is essentially a bridge of bringing it all together using key Intel technologies together with our platform. So as you can see on here, these are some of the products that we use from Intel and how we really use that to scale our AI use cases. Really quickly, in terms of how customers consume Viana, in Martin's AI Playground solution diagram, you'll see that it's always a variant of this particular methodology. So it's the edge device, and that scales depending on the number of cameras, sensors, and the use case. But essentially, what we need: an edge device, a camera, and the particular Viana license, and then we can deploy the use case. So when it comes to Viana packages, we operate very similarly to Adobe Creative Cloud, where you can purchase a specific module. So say you want just Photoshop, you can get just Photoshop. If you want just PDF, you can just get PDF. That's the same with us. We bundle it so that customers can get a variety of modules and different packages for what they want to use. So we've got Lite that has basic use cases, and that grows up the scale where if you get standard or premium, as you can see, you can get multiple use cases with that licensed tier across your fleet of sensors and devices. So we wanted to end off with this little statement and a little bit of a teaser. Martin and I are talking to a local marketing agency that's tagged to Intel as well. We have a school in Victoria that is putting the AI playground as part of their curriculum. So that's the Bendigo Tech School. The key outcome is really to make sure that the STEM, or rather what they call STEAM here, curriculum continues to grow, and they want to expose their students to as much of AI and building and growing and learning through computer science as much as they can. So this is something that we're doing with them. And yeah, there's going to be a video soon. We're planning for a video. So as soon as that's out, I'm sure you'll hear about it through our various social media channels as well. So continue to follow us on LinkedIn as well, so that you can get as much information as you can from us. So thank you so much. I've put on the screen here as well our emails, a little QR code as well for my LinkedIn if you want to contact me or have a look at anything else. If not, thank you so much. I hope that made sense. As usual, any questions, please do reach out.